Hi, it's me, Morse. So, I'm coming after a long time. Like it's been 2 days, I'm not uploading anything because my exams are starting from what is this month? I mean, 6 June. Okay, my exams are starting on 21st June, from 21st June, and yeah, I mean, that's the reason I was like completing my assignments. I'm a lazy person because I don't need college. It's a college. Okay, so fuck that. So, today I learned something new, which is binary search. Binary search is something, yeah. I didn't know we can do that. I mean, I already know. I attend a class, which is from Harvard. I mean, the Harvard CS50, the Harvard CS50 classes. It's a 24-hour long video. I mean, it's a long, like it's a nice video. So yeah. So basically, I'll come across your linear search, and then I know about the binary search, and it's pretty easy. So let's just explain our Betty, and I'm going to solve a problem also. So let's go. First of all, like learn what is binary search. Let's just little bit. Okay, how a linear algorithm search and how a binary search work. Okay, so let's suppose we have this array of 13. We want to find k is equal to 9. Okay, we have to find 9. Okay, so how a linear algorithm work? So a linear algorithm, so in here, this is a array. We have to find the 9 value. So how we going to find? So in linear algorithm, we run a loop and it's going to compare if our the key is equal to our array number 1. It is not then 2. It's not. So how many function does it take? I mean, how many op operation it take to find our 9? 1, 2, 3, 4, 5. It take 4. I mean, 1, 2, 3, 4, 5, 6. It take 5 operation to find our 9. But in linear search, what we do is basically find our. Okay, so the first thing in our binary search, we can't use our binary search outside a sorted array. Okay, it's only going to work inside a sorted array. Let's suppose in here the mid value is 7. Is our key is less than 7? If yes, if it's less than 7, then it's going to run this kind of loop. So it's going to part this wise, but the 9 is greater than 7. So it's going to divide another time. We have to find a middle value. So we are only going to use our operations in this part of array, this 9, 11, and 13. Why? Because we get this value. It's as simple as that. Then it's going to count between these values. So we have to find another middle. If this middle is, so let's suppose this middle is 11. Yeah, it is the middle. Then if this 9 is greater than evil, so choice. Okay. So if going to count, so this is going to calculate if our 9 is smaller than 11. Yes, it is smaller. So it's going to count this value 7 and 9. What is the mid of 7 and 9? 9 is 9. Okay. So it's going to calculate another time. Is our 9 is smaller than or is equal to the value, our key? It is. So it's going to run our this thing. So it takes 3 operations only. First step, second step, third step. It take only 3 operations to find the value. And in linear algorithm, like in linear search, we have to calculate 6 time. It take 6 operation to calculate this thing. So there is another problem. So there is a problem in 704 binary search in LeetCode. So we're going to solve this problem. It's like pretty easy though, binary search. So let's go to VS Code. So let's just int mm, int n is equal to nums size. On this, then int we have to first of all find the starting and the ending value because without first, okay, so how we are going to calculate our mid value, the middle? How we're going to count the mid value? To count mid, what we can do is basically to count the mid, what we can do is basically start start plus end is divided by 2. This should be inside a bracket. Okay, this should be inside a bracket. So this is how we can find our middle. Okay, to find a middle, what we can do is this perform this thing. Okay, to find, so let's say, so first of all we have to find the starting and the ending value. So what is the starting value, which is integer 0? Integer 0 is the starting value, and what is the highest value? It's basically the length of our array minus 1. So I am int st 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 is equal to 0, and to find end minus 1. Now let's go into while loop. What should be the while loop? So when our loop is going to stop? When is our loop is going to stop? When our starting and ending value is greater than and equal to, because then it is the answer. If the starting value and end value is same, then this is the answer. I mean, so let's say st is greater than and equal to end, then our loop is going to stop. Okay, then let's find the mid. Mid is basically, so this is our mid value. To find our mid, so if we find our mid, then we can, then what we can do is basically use our if statement. If our the key and the middle value is greater than or smaller than, then we have to find that. So to find that, what you can do is basically add a if statement. Hmm. If, what are a condition? Target is greater than, if a target is smaller than the nums of mid. Okay, so if our this number, if our target is smaller than, so then this loop is going to this. So we have to change our end value to this. How we can change our end value to this is basically, let's copy this thing out. So how we can do this? So if we want to do this, then end is equal to the mid minus 1. This will be work. Okay. So end minus 1 is basically what in here we do is basically the mid minus 1 is our the starting value now. So this, okay. Then else if target is greater than nums mid, nums mid, then and no, and start st st is equal to, start is equal to mid plus 1, I think. Mid plus 1, else return mid mid. In here I will return minus 1. Okay, so let me explain this, how this if statement is working. Okay, so the first thing is what I'm going to do is basically calculate if our 9 is smaller than the mid value. If this is small, then what we can do is basically shift our end value to here, shift our end value to 6. Then this loop is going to again find the mid value starting with 1 and ending with 6. So we just change our, okay. So now this 7, 9, 11, and 13 doesn't exist. Now we have another array which is this number of 1, 2, 3, 4. This is 4 values of the array. So it's just working like this. And if this is bigger than this, then we're going to kind to count with from 9. We're starting with 9, 9, 11, and 13. It's like work this. And this, and two things, if this two things doesn't work, if if this is not smaller than the target and this is not bigger than the target, then this should be the middle value. Let's suppose this is 7. The 7 is not smaller than these values. The 7 is not bigger than these values. The 7 is the value. So then we're going to run this. And if we get a if we get a key value which is not included in this array, then what we can do is basically return -1. I mean, we didn't get the array. Binary search, but we can optimize this thing, okay? In here, in this mid value, I can do this. So basically, let's think. We're calculating our mid value. What are the how to calculate the mid value? We're plusing the starting and the end. The start is integer and end is also a integer. So if in the worst case scenario we get the maximum number of integer, the int max integer, then we can't calculate because that's just too much, because that's just like literally so many numbers. I mean, we can't store that many numbers inside an integer. So what we can do in here is basically do is mid is equal to start start plus end minus start divided by 2. This is as simple as it. I mean, in mathematically, it's just going to work like this thing. Like in mathematical way, it's just going to work just as this middle, what is that called? I mean, middle formula work, but in but like in computer science, what we're doing is basically we are not storing so many integer inside an integer. What we are in here we're doing is basically dividing two integers, the max integers, int max integer. So then we can get a smaller integer. Okay, did you get it? So it's like that. So we can optimize this in this way. There we go. 0, 100%. We're in the top. This is the whole binary search. So, yeah, solved it. The binary search. It's pretty much easy. Like it's way easier than a linear now. Linear search is also easy, but this is a more optimized version. Uh, we can use inside a sorted array. It should be descended or ascended. Don't know what is that called, but yeah. So this is the today's video. I hope you guys like this video, like all things. Bye bye. Peace out. Betty is good. So Betty is properly understanding this code. So in his opinion, this is the most optimized.